So let's think about momentum conservation for a second.
Right.
Right. So so it's m1 times v1I. So our first object is the rocket.
Right.
Plus m2 v2I. Our second object is the blob. And then they're going to collide m1 v1 final plus
M2 V1 final, or V2 final.
All right.
But then we know that these are identical.
That's right. So if these are identical, then we can rewrite this as m1 plus m2 vf, where I can't see that. So v1f equals v2f, and so we can just say that v1f equals v2f equals vf. Okay? And then what do we know about the initial speed of the blob and what we just did?
Okay, so the way we had it was 0.
Right, so initially this was 0. And then do you remember what this was?
50, I believe.
Right, so that's 50. And do you remember the mass of the
I think it was like 3.
ship? Yeah, so the mass of the ship is 3. So 3 times 50, right? And so that gives us, this whole thing is equal to 150, right?
Yeah.
And then if this is 3, right, because the mass of the ship is 3, do you remember the mass of the blob?
Is it like 10?
Yep, so it was 10. Okay.
Times VF.
And then we don't know what VF is, right?
Right, but we have enough information to solve for it.
Right. So this is 13.
13.
So VF is going to be 150 divided by 13. I'm told that this is 11.54. I can't actually do this math in my head.
Yeah, I was just going to say approximately 10.
Having a PhD in physics does not allow you to do this in your head in a millisecond, okay? But this is what you get. You get 11.54. But our program, you remember what we got after they collided?
Well, wasn't it just 50 because it kept the same one?
Exactly. So that's way too fast. It should be more like 11.54.
Right,
So,
okay.
So we've got to take this code, and we've got to configure it so that this happens after they collide. They should be going much slower.
Okay.
Because the blob is so heavy, right? So let's look at our code and see what we can do about that.